Good evening. Oh, mute that. All right. Good evening. This is VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, almost regular, coming to you from the studios of VK3CSJ in Narre Warren South. A very pleasant good evening to everybody on this 25th of April, Anzac Day, lest we forget. Trust everybody is okay and that your favourite football team is winning, or has won. Mine didn't. Good evening anyway, and apologies for not being around last Friday. I'm almost not here tonight. The Pro 3 that I use as my key transmitter for 80 metre transmissions, the IC756 Pro 3, only came into life about 10 minutes ago, less than 10 minutes ago. It's got a receiver issue, and even though it seems to receive okay, the band scope has plenty of noise on it, and I can make out received signals, but there's very little audio, and there's no signal meter indication. The meter is on 0, but it does come good. Normally it started out after about 15-20 minutes or so it would come good, but I turned the receiver on probably about 2 hours ago, and it finally came good at 10 minutes to 10. I was about to use another radio, but that was going to be awkward because it's got its own microphone. I can't use this Heil microphone. But fortunately, the Pro 3 decided to come good. Hopefully it'll stay good for the next 60 minutes or less. Anyway, that's just some of the problems here in the shack, and even the antenna that I use for the ATV repeater is at a lower angle, lower height, and in fact I'm working on my antennas at the moment, and there could be a period coming up where I might be off air for a number of weeks until I get things sorted out, actually, but we'll see. Anyways, let me just check my Discord, because I've only just got the YouTube stream running, and there is visions on Discord, and there is audio as well, and I can see that Bruce, David and G'day Mike, they're all tuned into the Discord channel, which is interesting because I would have to press this button for that to work as well, and let me just check Discord again. Yep, it's still working. Okay. It's just a thing in vMix that I need to do for Discord to work, and it wasn't selected, but pictures were still there. Go figure. Anyway, all right. Anyway, yes, so we're also broadcasting on the Melbourne TV repeater, VK3R TV, which can be tuned to on a set-top box, 445.5 megahertz, with a HD box, DVB-T2 box. More information about VK3R TV can be found on the Amateur Radio Victoria website. There's one whole page dedicated to what VK3R TV is all about, where it is and how to receive it, and it's useful information. Anyway, because it was such a rush to get here tonight, and not sure that I was, I'll go into things fairly quickly here and see if we can get it tonight over and done with quickly. Mumble. All right. Just a little bit of the blurb about the ASV for those that are tuning in for the first time. Information about what I do, the station, I guess, in general, that is to say VK3 EKH, can be found on my QRZ.com page. Under that call sign VK3 Echo Kilo Hotel, VK3 EKH, just look on the QRZ.com page for information what's going on here, and also on Discord. as I say every week, Discord is far better to view the graphic and pictures and visions as opposed to YouTube, because YouTube's got that 20-second delay. If you can tolerate that and listen to my bilge, then that's okay. But otherwise, I think Discord is the better medium, because the vision is less than a second delay from what you're hearing here on 80 meters live. Anyway, all right. The ASV, Astronomical Society of Victoria, is a non-for-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,800 members now. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at our two metropolitan locations. One's the Morley Community Village, and the other is the Melbourne Observatory. And we host monthly astro talks at the herbarium near the Melbourne Observatory. The Society's library is also located at the Melbourne Observatory and is open during when the astro talks are occurring, that once a month. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. Our members conduct astronomy for the people gatherings throughout the year, bringing telescopes and astronomy to Melbourne's parks and schools. Please check the calendar for details if you are interested in popping along to one of these street events. The calendar is part of the tab on the main webpage under the events. I think it's under the events tab. Let me just check that. Yep, if you click on the events, you've got calendar right below that. The ASV is currently involved in a number of major projects. We are involved in the restoration of the Great Melbourne Telescope after it being all but destroyed by the fires up there at Canberra a few years ago, and are also currently working on the installation of a series of remote telescopes at our dark sky site, the Leon Mao dark sky site just north of Heathcote. A lot of those domes with automated telescopes, I think there's just 3 of them, are now practically functional. I think they're still ironing out just a few things, but members can book time on those remote telescopes to do observations if they wish. And I might explore that myself at some stage. Thanks to the generous donation from a Silent Key member of the ASV, Leon Mao, who donated the land up there at Heathcote to the ASV many years ago. The site is named after him, Leon Mao Dark Sky Site, and is located north of Melbourne, has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope there. There's also a larger one, 40-inch, and there's also a wheelchair accessible telescope, 16-inch, at the dark sky site, which and there's also a fully steerable radio telescope up there too, a Kennedy dish, 8.5 metre fully steerable radio telescope, which members can get involved with through the radio astronomy section. The annual yearbook is supplied to members, as well as a bi-monthly newsletter for those watching the visions. This is the annual yearbook that gets published, a very decent publication. It's like an almanac of some sort for optical astronomers, full of information about what's happening throughout the 12 months. It's a good reference. And of course the newsletter, which is this bloke, slightly thinner, but it's nice and colourful and matte finish to it, and semi-gloss, I suppose. But that's the newsletter holding up there, and that's the logo, ASV logo, you can just see just there. So you get all that if you become a member. And of course becoming a member is easy peasy. Just go to the ASV website at www.asv.org.au. That's www.asv.org.au. Just type in Astronomical Society of Victoria in your favourite search engine, and you'll very quickly find the site. And yes, so becoming a member is via the website or via PayPal, and you'll receive a members pack in a week's time or so, which will give you all the information you need to know, what you need to know about accessing the Dark Sky site up at Heathcote, and all the other information, and I think they still issue membership cards as well. So and of course then you've got access to the library too. And as I say, the library is an outstanding environment, because there's a zillion books in there going back many tens of years in publication date. I think just about every magazine that's ever been published is also available there as copies to borrow, and I think there's even some particular book that's kept actually not in the library but kept in a secure location because of its delicacy and its rarity and its importance to astronomy. I can't recall what it is right now, but I know that there is such a book that the ASV does have in its possession. Yeah. All right. And I think that's about it, really. The ASV is governed by a set of rules which should be read before applying for membership. And there's a big link to the ASV rules there on that page. And then just below that is a list of all the presidents that's been and gone since 1922. Quite a few. So, yeah. That's the main ASV homepage anyway, or the website. There are various section directors or sections too. I'm sorry I'm not quite with it tonight, I can tell. I'm not quite there. I've had the whole week off. It's been an Easter week, and I've been averaging 3-4 o'clock nights, so yeah, I've been completely stepping out of my usual routine. Anyway, enough of that. You've got these are the sections: astrophotography, club section, comet and meteor section, computing section, cosmology and astrophysics, deep sky, historical section, instrument making, juniors, lunar and planetary, new astronomers group, radio astronomy, solar astronomy, and space exploration. So if any of those sections or groups sound of any interest to you, again, go to the ASV website, look under the sections tab. All those sections that I've just read out have their own separate page, and I think in most cases there is contact information for the section director, so you can contact the section director and just as a member of the public, ask if you can pop along to a meeting as a visitor and see if it's of any value to you, and the section director will talk to you about if you want to come to further meetings. Just think about becoming a member as well. So there's lots of benefit there. All right, you're tuned to ASV Radio, VK3EKH, and on this Anzac Day. There's no Timothy report tonight. Timothy's Timothy Scove, our space weatherwoman. She published a video just last week, which would have been okay for last Friday if I had been on. But there's been no new or recent video. So we'll stick to the usual solar report tonight. Okay, astronomy. Where am I? Okay, first article for tonight, which has a beautiful picture of the sun. So I shall just bring that up. There it is, this one here. And look at that. For those watching the video, if you've never seen the sun before, there it is. Okay, courtesy of astronomy.com. Before Einstein, what did astronomers think powered the sun? Have you ever wondered that? We've wondered what powered the sun for centuries. Early guesses included meteor showers, chemical combustion, and contraction. The question of what energy source powers the sun has been around for literally centuries. During the 1800s, some thought that a constant shower of meteors into the sun might do the trick. Others considered and rejected any number of chemical combustion processes. Independently, William Thomson, also known as Lord Kelvin, and Hermann von Helmholtz came up with the idea of solar contraction in the mid-1800s. This is usually called the Kelvin-Helmholtz contraction theory. It proposed that the sun is contracting slowly, and this contraction heats the star up, converting gravitational potential energy into kinetic thermal energy. Both performed the requisite calculation and came up with a solar lifetime between 20 million and 500 million years. However, this was in many cases much too short to be compatible with geologic evidence of the age and evolution of the mountains on Earth. Nevertheless, it was our best guess as to the origin of solar heating, and it held sway until the dawn of the nuclear age. In the 1920s, Sir Arthur Stanley Eddington developed the concept of proton-proton fusion, which converts hydrogen into helium. Then Hans Bethe in 1938 worked out the details of the carbon-nitrogen-oxygen, or CNO, nuclear fusion cycle, which also fuses hydrogen into helium. Both of these processes cause mass to be lost. Finally, Einstein's iconic formula, E equals mc squared, was indeed the mechanism that explained the conversion of the liberated mass into nuclear energy in the quantities needed to power the sun and stabilize it against gravitational contraction, as we know to be the case today. And they've got a little diagram here, which I'll just bring that up as well, part of the article. So what you're seeing there in this diagram is the proton chain left. On the left side is the chief fusion mechanism by which the sun produces energy. During this reaction, 4 protons, hydrogen nuclei, combine to create one atom of helium-4, the most common form of helium. In the CNO cycle at the right, carbon-12 goes through several conversions, becoming various isotopes of nitrogen, carbon and oxygen, before returning to carbon-12. The last step produces helium-4. In both processes, some small amount of mass is lost and transformed into energy. And that's what's being described in this chain diagram. Oh, that's the end of the article too, by the way. So there it is, a little bit about what goes on in the sun. Without the sun, of course, we wouldn't be here. So I can understand people of ancient origins worshipping the sun, thinking that was some sort of god in the sky. Oh, well, there it is. You're tuned to ASV Radio VK3EKH, the official station of the Astronomical Society of Victoria, with the regular, more or less, Friday night broadcast. Next is this one, courtesy of astronomy.com again, and we have a graphic for this one as well, which I'll bring up straight away. If I can find it, it should be just here. There it is. Alrighty then. Was there ever a planet between Mars and Jupiter? Have you ever asked yourself that question? It is highly unlikely a planet ever existed in this location, where the main belt of asteroids orbits, as you can see in this diagram. And in this diagram, there's a little bit of a blurb about this. The majority of known asteroids orbit in the main belt between Mars and Jupiter. It is unlikely that many bodies here were ever part of a single planet. This illustration on the screen at the moment shows the positions of the planets and all numbered asteroids on Jan 1, 2018. All numbered? Okay. Anyway, going back to the article. Where are we? Oh, yep. Is there evidence of a planet ever existing between Mars and Jupiter? Question mark. It's a splendid question and gives us an opportunity to distinguish between what we know and what we believe might be true. First, we know that myrid small bodies orbit the Sun between Mars and Jupiter. These objects are the asteroids that comprise the main belt. Astronomers estimate that 1.1 million to 1.9 million asteroids with diameters equal to or exceeding 1 kilometre are located within this region, with millions more smaller asteroids likely lurking as well. That's quite a substantial number of rocks. It would seem as though that those asteroids could form quite a planet if put together. But surprisingly, if all the main belt bodies were to coalesce, the resultant world's mass would only be 4% that of the Moon. So, to put that value into perspective, as it says here, the Moon's mass is only 1.2% that of Earth, and half of that mass is concentrated in the four largest bodies, Ceres, Vesta, Pallas and Hygiea. The notion that these fragments could have come from a planet that was somehow reduced to fragments arose out of the 1801 discovery of Ceres by Giuseppe, got it, yep, I knew it, Giuseppe Pazzi, and the 1802 discovery of Pallas by Henrik Olbers. Olbers became convinced that these two bodies were pieces of a larger world that once existed, and the subsequent discoveries of Juno 1804 and Vesta 1807 lent credence to this belief. The hypothetical doomed planet was soon thereafter given the name Pantheon, after the ill-fated son of Greek sun god Helios, who tried to drive his father's chariot for one day and perished as a result. This idea evolved into what was known to the 20th century as the disruption theory, which stated that a planet between Mars and Jupiter had been destroyed by some unknown means, perhaps tidal interactions with Jupiter or a collision with another body. Could the main belt have formed from the remains of a destroyed planet? Question mark. How could we know one way or another? Question mark. One important clue practically fell into our laps. Iron meteorites on Earth that are known to have come from the main belt have been determined not to have all originated from the same body. The patterns within these meteorites are quite different from one another. Fragments of a single world would show some similarities. The analysis of these meteorites, combined with the comparative dearth of material within the main belt, leads us to believe that no planet ever existed between the orbits of Mars and Jupiter after all. And the asteroids are likely just remnants from the early days of the solar system formation. Moreover, we shouldn't expect any planet to form within the main belt in the future, since Jupiter's considerable gravitational influence keeps the asteroids in a perpetual spin cycle, preventing them from gathering together to make a new world. We can assert that no planet ever existed between Mars and Jupiter. We can, however, say that it is highly unlikely one ever did. So, courtesy of astronomy.com, was there ever a planet between Mars and Jupiter? I gather that was never the case. It's a fair enough question. You're tuned to ASV Radio, VK3EKH, the official station of the Astronomical Society of Victoria. Okay. Our next article for tonight is this one. And there's a picture here for this too, which I shall bring up. Where are we? There it is, this interesting image. Righto. Amateur astrophotographer captures a stunning galaxy 24 million light years from Earth. And there it is. If I can ever collect a picture like that when I get my dome finally up and running, I'll be very, very, very pleased. But there it is. There's a picture from an amateur astrophotographer. So anything is possible. All right. This is published 2 hours ago. A portrait, 32 hours in the making. So it took 32 hours to get that image. I'll accept that. Let me see. Where's this article start? Astrophotographer Ron Breacher has captured a stunning deep sky image of the spiral galaxy M106, located 23.5 million light years away in the constellation of Canes Venatici. Canes, Venati, whatever. Breacher imaged the distant galaxy for a little over 32 hours on nights spanning from March 27 to April 17, 2025. The finished portrait reveals the swirling arms of M106, focused around an active red-hued galactic core, an active star-forming region that is home to a ravenous supermassive black hole. M106 is classified as a Stayfort galaxy, which means that it has an active nucleus, explained Breacher in a post showcasing the image on his website. He said, "It's thought that part of the galaxy is falling into a supermassive black hole near the center. It is sort of cannibalizing itself," he says. While M106 is too faint to be spotted in the night sky with the naked eye, it is an excellent target to view with a small telescope. Though, as noted by NASA, a larger telescope would be needed to resolve the finer details. To find M106 in the northern hemisphere, stargazers need only locate the Big Dipper asterism of Ursa Major. Yeah. What else do they say here? But M106 isn't the only galaxy in this image. The other predominant galaxy at the lower left, that other little one there at the left there, is NGC 4248, Continued Breacher. It also shows Pink Nebula. There are many more galaxies in this image. Look for fuzzy patches of needle-like structures that look different from the sharp, round stars. Breacher wrote on his website that he never believed that he would get into astrophotography, but became captivated by the pursuit after buying a 4.5-inch reflector telescope for his son and watching the night sky while soothing his newborn daughter. His first forays into imaging the night sky saw Breacher capture the moon by holding a point-and-shoot camera up to the eyepiece of the Celestron Ultima 200 Schmidt-Cassegrain telescope. He has since experimented with numerous cameras, mounts, scopes and software to image cosmic objects ranging from Earth's moon to monstrous deep sky galaxies. Breacher's latest portrait of Messier 106, M106, was captured from his home outside the Canadian city of Guelph, Guelph, using a Celestron 14-inch Edge HD telescope, not exactly cheap, and situated in a sky shed enclosure, which is, as the name suggests, is a purpose-built shed with a removable roof. Breacher processed the images he captured using a series of red, green and blue and hydrogen alpha filters with his with his CMOS QHY 600M astronomy camera before processing the resulting data in a program called PixInsight software. If you are looking for a telescope or binoculars to observe galaxies like M106, our guides for the best binocular deals and best telescope deals now can help. This is the onastronomy.com website. Anyway, there it is. So, yeah, that galaxy there, M106, located 23.5 million light years away, and with 32 hours of imaging and a little bit of processing here and there, and appropriate filters on the telescope, you can get that kind of an image. And it is just stunning. It really is quite stunning. I just find that amazing. Okay, let me bring up my other camera. The color balance on this camera is a bit funny too. I'm not sure why. Did have the balances right, but the difference between these two cameras is just odd. Don't know why. I'm going to have to look at that one. Anyway, time is 10:34. And my streams are still holding up, which is good to see. Next. Okay, we're celebrating 35 years of the Hubble telescope, gifting us 4 breathtaking cosmic images. So the Space Hubble telescope, which was going to be retired at some point a few years ago, but they decided, no, we'll keep it going. Because universities and astronomical groups around the world can actually access, they can get permission to access or suggest astronomical things to picture or image, and can set up an arrangement where they can use the Hubble, which is interesting. I think that still happens. Anyway, so Hubble celebrates 35 years of gifting us 4 breathtaking cosmic images, and we can show you those in one slide at least. There we go. Okay, so in this image here, you've got Mars, then the Rosetta Nebula, the planetary nebula NGC 2899, and the spiral galaxy NGC 5335. I've got better images, separate images later on during this article. Anyway, it says here that this week brings the Hubble Space Telescope's 35th birthday, but instead of getting presents, the Hubble's team is giving out presents in the form of 4 views of the cosmos, ranging from a glimpse of Mars to a glittering picture of a far-out galaxy. It's the latest observance of a tradition that goes back decades, in which NASA and the Space Telescope Science Institute released pictures to celebrate the anniversary of Hubble's launch into Earth's orbit aboard the Space Shuttle Discovery on April 24, 1990. Hubble opened a new window to the universe when it launched 35 years ago. Sean Goldman, acting director of the Astrophysics Division at NASA headquarters, said today in an image advisory marking the occasion. He said, "The fact that it is still operating today is a testament to the value of our flagship observatories and provides critical lessons for the Habitable Worlds Observatory, which we plan to be serviceable in the spirit of Hubble." Hubble didn't get off too smooth a start, though, as I think we all know. After the 24,000-pound observatory was deployed, scientists discovered that its nearly 8-foot wide mirror had a manufacturing flaw. In 1993, during the first of 5 servicing missions, astronauts installed hardware that greatly improved the sharpness of Hubble's images. Since then, Hubble's observations have revolutionized astronomy, contributing to discoveries related to exoplanets, black holes, the nature of early universe, the existence of dark energy, and the accelerating expansion of the cosmos. NASA says Hubble has made nearly 1.7 million observations so far, focusing on about 55,000 astronomical targets and resulting in more than 22,000 research papers. All those discoveries and all those images endeared Hubble to the general public. The loss of the Space Shuttle Columbia and its crew in 2003 led NASA to suspend plans for much needed repairs, but because of the resulting outcry over the telescope's potential demise, the space agency agreed to a final servicing mission that took place in 2009. At that time, NASA expected the telescope to provide dazzling views for an additional 5 or 10 years. Once again, Hubble exceeded expectations, racking up 16 years of operation without an on-orbit or in-orbit repair. Just bring up another picture here of Mars taken by the Hubble. The images released today illustrated the breadth of Hubble's range. Pictures of Mars were captured between last December 28 and 30, near the time when Mars is at its closest approach to Earth. The images show the planet's bright orange Tharsis Plateau and its dormant volcanoes in the North Polar ice cap and the wispy water ice clouds. Stunning images. Then there's another image. I think it's this one coming up next. Yep, hang on a sec. Do that. Another Hubble image from last December focuses on a small portion of the Rosetta Nebula, a huge star-forming region 5,200 light-years from Earth. Dark clouds of gas laced with dust are silhouetted across the image. Yes, looks good on the TV screen here. And the next image is this one. Coming up, lots of key clicks. The Hubble team also released a wider scale image of the nebula to add cosmic context. Oh yes, so that last image that we saw, you can see the insert there. So let me see. So that last image we saw, this one is in fact when you pull back the zoom to reveal the overall nebula that's taken in. So that's a small part of this nebula, and as you can see by the insert picture there, pretty amazing, eh? So the background image is from the digitized sky survey, while the insert is a small portion of the nebula as photographed by the Hubble Space Telescope. In January, Hubble snapped a picture of the planetary nebula NGC 2899, which is this guy. And the colourful clouds of dust and gas have been shaped by the radiation and stellar winds blasting out from the star at the image centre. And then Hubble produced a new view of the spiral galaxy NGC 5335 in March, which is this one here. And the picture reveals a bar-shaped structure that slices across the galaxy and channels gas inward towards the centre, fueling the production of new stars. Patchy streamers of star formation swirl around the edges of the galaxy. These are real images. They're not AI, generated by AI or anything like that. In the recent years, just bring myself up there. In recent years, Hubble has been experiencing periodic hiccups, and it's only a matter of time before a glitch puts it out of commission permanently. Meanwhile, the spotlight has been shifting to NASA's James Webb Space Telescope, which was launched in 2021 and has 7 times as much light gathering capability as the Hubble does. Unlike Hubble, James Webb Space Telescopes sees the universe primarily in infrared light. It doesn't have Hubble's capability to make observations in a wide spectrum ranging from infrared to ultraviolet. And because JWST is positioned at a gravitational balance point a million miles from Earth, it can't be serviced in space as the Hubble was. In contrast, the Habitable Worlds Observatory would study the universe in visible and ultraviolet light, producing images that would be significantly sharper than Hubble's views. A major goal of the future mission would be to identify potentially habitable Earth-like planets orbiting distant stars. The HWO would also be designed with robotic servicing in mind. NASA's current plans call for the launching of the Habitable Worlds Observatory by as early as the 2040s. That's some distance off. Right, so you're tuned to ASV Radio. VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night cast missions. Now, we're coming to the end. We are coming to the end tonight. A little bit of a plug for Mount Burnett. I've got a slide here to put up, the usual slide. Mount Burnett Observatory is in the mountains, in the hills, up near Emerald, and it's about a 20-25 minute drive from here, Narre South. Looking at the main homepage here, they're saying that there's a public viewing night on the 10th of May. It's requesting some dollars to enter, but it is the 10th of May, which I suspect may be a Friday, possibly a Saturday. I'll just check the date on that. 10th of May, it's a Saturday. So yes, a public viewing night, 10th of May, and yeah, there's and a few other events occurring as well. So if you want to find out more information about the Mount Burnett Observatory, excuse me, just go to the website mbo.org.au. MBO, Mount Burnett Observatory, MBO, just mbo.org.au, or just type in Mount Burnett Observatory in your favourite search engine. The Mount Burnett Observatory used to belong to the Monash University many years ago. Lots of good research was done using that observatory through Monash, and then it became in a disused state for many years, and then a group of dedicated astronomers, amateur astronomers, decided to negotiate with Monash to see if they could get it, and they did. So congratulations on those blokes that got the observatory for us amateurs. Good stuff, isn't it? All right, I'm tiring here. Next thing on the list is space weather. Okay, so let's go to the latest view of the sun. So if the sun was in the sky right now, this would be roughly what it would look like. A great big round orange ball. It's not really what we're looking at though. It's all those sunspots that you can see in the image. There's about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sunspots that have been designated with a number system. And the solar wind is currently at 506.9 kilometres per second at a density of 0.99 protons per cubic centimetre. And there you see the disk of the sun. There's a little bit of coronal hole occurring at the moment, which I've got an image of that one as well. It's in those dark regions is where high velocity particles are streaming from the sun and out into space. It's the streaming of these particles that interact with the Earth's magnetic field to cause auroral activity as well. Although right now this is the current auroral activity over the Antarctica, and as you can see, it's fairly vague tonight. I've been watching it over this week, and the aurora australis has been quite strong over the last few nights, but tonight is quite minimal, so not much activity to mention there. What else have I got in here? Oh, this is the latest solar chart. If you're interested in where we are in the scheme of things from the solar cycle, there it is. So as I mentioned, pardon me, a few nights or a few days ago on the coffee break net on 160 metres to the guys there. We are. You could say when you look at that trend line on the solar cycle, we're effectively now heading down. I mean, sure, there might be a CME, or a couple of CMEs that might launch in the next week or the next couple of months. It might create a sudden peak, but it's now trending downwards. And if you look at that peak on that trend, I tend to think that we're now at the 1 o'clock, like 12 o'clock's the peak. So we're now at the 1 o'clock position, where each hour is approximately six, maybe 8 months long. I'm just throwing that out there. But yes, we're at the 1 o'clock position on the solar cycle now. That's just my little determination, no one else's. And so we're now trending downwards, is what I'm trying to say. And but if you look closely at the chart, by the time it gets down to solar minima, we're looking at around 2030. So quite honestly, the next 3 to 5 years is still likely to have a number of solar activity, which means good HF conditions from time to time around the world. And of course, sometimes when there's no communications at all. But anyway, there it is. That's what it's like living around the sun. Okay, what else is in the solar report? Where are we with the here we are, planetary K index? For those that are interested in that, the planetary K index is currently 1, which is considered quiet. And over the next 24 hours, it's predicted that the KP index will increase to 3.67, which is also considered as quiet. Spaceweather.com also reports that there is an interplanetary shock wave. An interplanetary shock wave struck Earth's magnetic field on April 24 at around 7:07:15 UTC. What is an interplanetary shock wave, you might ask? Well, it's an abrupt change in the solar wind, probably a CME that we didn't realise was coming. This one sparked auroras in New Zealand, but no global geomagnetic storm was announced. Yeah, so this is what I've noticed. I didn't realise this until now, but I've got a screen runs all the time here, and it's got the North and South Pole auroral oval on the screen, which updates every couple of minutes or so. And I've been noticing how it's been fairly active over the last few days. So there it is, interplanetary shockwave. There's also something about Starlink here. The Starlink incident is not what we thought. It never made sense. On February 3rd, 2022, SpaceX launched a batch of 49 Starlinks to low Earth orbit, something they had done many times before. This time was different, though. Almost immediately, dozens of the new satellites began to fall out of the sky. At the time, SpaceX offered this explanation. Unfortunately, the satellites deployed on Thursday, the 3rd of Feb, were significantly impacted by a geomagnetic storm on Friday, the 4th of Feb. A more accurate statement might have read, impacted by a very minor geomagnetic storm. The satellites flew into a storm that barely registered on NOAA scales. It was a G1, the weakest possible, unlikely to cause a mass decay of satellites. Something about the Starlink incident was not adding up. Space scientists Scott McIntosh and Robert Limon of the Linker Space Incorporated company have a new and different idea. They seem to think that it was the Terminator did it, says McIntosh. Not to be confused with the killer robot, Macintosh's Terminator is an event on the Sun that helps explain the mysterious progression of solar cycles. 4 centuries after Galileo discovered sunspots, researchers still cannot accurately predict the timing and strength of the sun's 11-year solar cycle. Even 11 years isn't real. Observed cycles vary from less than 9 years to more than 14 years long. McIntosh and Lehman realised that forecasters had been overlooking something. There is a moment that happens every 11 years or so when opposing magnetic fields from the sun's previous and upcoming solar cycles collide and cancel. And they called this moment, which signals the death of the old cycle, the termination event. After a termination event, the sun roars to life, like a hot stove where someone suddenly turns the burner on. McIntosh likes to say, solar ultraviolet radiation abruptly jumps to a higher level, heating the upper atmosphere and dramatically increasing the aerodynamic drag on satellites. And there's a couple of plots here. I haven't copied these plots across, but they show the what was going on at the time. There's a histogram that shows a number of objects falling out of Earth's orbit each year since 1975. There's vertical dashed lines in the chart here mark termination events, and there is an uptick in satellite decay around the time of every terminator, not bigger than 2022. As SpaceX was assembling the doomed Starlinks of Group 47 in early 2022, they had no idea that the Terminator event had in fact just happened. Unwittingly, they launched the satellites into a radical altered near-space environment. Some of our satellite partners said it was just a pea soup up there, says Lemon. SpaceX wasn't the only company hit hard. Capella Space also struggled in 2022 to keep a constellation of synthetic aperture radar satellites in orbit. The atmospheric density in low Earth orbit was 2 to 3 times more than expected. This increases in drag threatened to permanently deorbit some of the spacecraft. Indeed, many did deorbit early than the 3-year design lifetimes. The Terminator did it, ? It makes more sense than a minor storm, is what they say here. That's an interesting one. I wasn't aware of that one. The Terminator event, or the termination event, in relation to the sun's magnetic field and the way it operates. Fascinating stuff. For more information, just go to spaceweather.com on that, because there's a couple of graphs. There's a couple of images here that are showing the details and the graphs. So more information can be gleaned from spaceweather.com today. The radio sun at the moment is 170 solar flux units. I forgot to mention that before. The sunspot number is 152, and the radio sun is 170 solar flux units. I think that's about it. As of April 25, 2025, there were 2,349 potentially hazardous asteroids, but none of those are on a collision course with Earth at this present point in time. All right, I've managed to get through that with reasonable success, and it looks like the streams have held in, which has been good. But now I am going to call stations in, and this is generally where the streams fall over. So if the YouTube falls over or Discord falls over, my apologies. But at least you've got the last 60 minutes uninterrupted one way or another. All right, I think I'm ready to go here. This is VK3EKH, listening on 3541 for any stations wishing to check in.
VK3GL Bunyip. VK3SPX.
Right, VK3GL, VK3SPX, anybody else? Righto, I think everybody's still watching the football. Oh, it's finished anyway. All right, have a say, Gray. VK3 Golf Lima in Bunyip, VK3 EKH.
Yes, good evening, Chris. VK3 EKH, VK3GL. Yeah, thanks very much for the broadcast. listened pretty much to all of it this evening. Being a Good Friday, or being a public holiday, I should say more correctly, there's not a whole lot happening at work. I've been on shift since 3 o'clock this afternoon, finishing up in about an hour's time. Yes, all very interesting on what information was passed on. Quite interesting, the theories around what keeps the sun on fire. Interesting things. I don't think anyone will really know what actually does that, but it's quite phenomenal to think that the thing is estimated to burn between 20 million and 500 million years. Quite a broad estimate, to say the least. But she's been going on, been burning for quite some time, and it is quite remarkable where it gets the energy to be able to burn for that long. That's for sure. Anyway, about solar cycles being on perhaps a downward trend, I would like to, I hope to think that peak might hang around for a bit longer, but nevertheless it's inevitable that it is going to start to head in the other direction. And you say the minimum is going to be another 5 years away at 2030. That means that the next peak we're probably expecting around 2035, 36, which will mean that that'll be another, I'll be 70 by the time that happens, and then maybe the next one I'll be about 81 or 82. So I think at this stage I'm probably, if I'm lucky, I might get 2 more solar cycles before I expire. At least I'm hoping that I'll get another 2 and can remain relatively active on the radio for that period of time. I won't only just be an old timer by then, I'll be an old, very old timer, I guess. Alright, Clint, thanks again for the broadcast. Good signal here on 80 metres. A few little crackles and pops this evening. Well, we've had the rain front go through. It's been pretty much steady rain here for the last 7 hours or so. Not heavy at all, but just sprinkling all the time. And I think at the last look we've had about 11 millimetres of rain. So, which is good to give the garden a bit of a treat, that's for sure. Back to you, Clint. Thanks again. Good signal here on 80 VK3, VK3GL in Bunyip.
Yeah, righto, Graham. VK3 GL in Bunyip, VK3 EKH returning. And you're also a good signal, 20 to 25 over 9, and a little bit of QSB, but sounding absolutely magnificent. So not a problem about that. And yes, there's a lot to learn about the sun. I mean, having a star only 150 million odd kilometres away, so close to us. It's and several probes that are out there taking really close images. We can learn a lot about the sun and the processes going on, and even to this day, some scientists that study the sun are still scratching their head over how's this thing work. I mean, we've got a pretty good idea now, but it's just a magnificent object. And once I get my observatory up and running, and I've got appropriate telescopes running and fitted out, I'll be very, very keen to do some solar photography, because some of the images that are coming through nowadays on solar photography with the appropriate filters fitted really capture amazing detail. It's just I'm just blown away by some of the images that can be gained. So looking forward to getting involved with a little bit of that too at some point. Will happen one day. Anyway, thanks, Gray. And yeah, today's been a bit miserable from a weather point of view. I'm working on my antennas, and there's not too much I could do today because of the rain. I have wasted this week a little bit. There's been more good days than there has been bad days, and I've spent most of it indoors. So yeah, but I would love to have another week off, but that doesn't mean that I get certain things done. It just doesn't work with me. Anyway, all right. Thanks, Gray. Across to you there, Steve. G'day to you. VK3SBX, VK3EKH.
VK3EKH. This is Delta X-ray 3.
There's no audio. Sorry, my apologies. I had my gain down. Here I am waffling away, and I didn't have my mic gain up. My humblest apologies. If it's not the microphone failing, it's because I've had the mic gain down. I've got to remember that. Dear me. And I've got these things in front of me that tell me whether there's audio there or not. I don't know. I stuffed that one up, didn't I? Anyway, I won't repeat what I just said. There wasn't much in it anyway. But what I will say is the article that you missed was from astronomy.com. So if you visit astronomy.com and go across to where it says Ask Astro in the tab section, Ask Astro, it's a question that a fellow by the name of William Fields asked. And before Einstein, what did astronomers think powered the sun? So that's the article I read. That was published on the 14th of April. Right. Having said all that, I went up to the next thing I did was to see if there's any other stations wishing to check in, and I looked at the radio and I saw no modulation. I thought, oh no, I had the mic going down. It's always something here. Is there any other stations wishing to check in? VK3 EKH listening.
Just for a quick comment again, Clint.
Yes.
I just wanted to make a comment, just an observation that I've heard unusually tonight on your transmission here on 80 metres, and I've heard it about 3 or 4 times. Maybe on stage or whatever, they tend to use a little bit of echo ambience, just a smidgen of it, on their microphone audio. And on 2 or 3 occasions tonight, I've heard this mild echo effect on your audio. Only briefly, but it's been there, and it's very unusual. Just something that I've never observed before. I've heard other sorts of effects on audio from multipassing and that sort of thing, but tonight just almost this slight ambience of echo in your room, but not there permanently. Just there 2 or 3 times, or maybe 4 times this evening that I observed that. I just thought that was interesting, and it must be something to do with some interesting atmospherics tonight, and maybe a little bit of a multipassing effect there, over.
Well, I think you'll find that's the mixer doing that. 1 2 1 2. I'm not picking it up right now, actually. Monitoring on the mixer, but I have noticed that 1 2 3 1 2 3 1 2. Yeah, no, I don't know. I'm not sure if that's an atmospheric thing that you're hearing, or whether it's this mixer doing something. 1 2 3 4 5 3 4 5 1 2 1 2 3 4 5 1 2 3 4 5. Yeah, I don't know. I'm doing various things here which could introduce that, because I have noticed it. 1 2 3 4 5, but it's not going to do it. 1 2 1 2 1 2 1 2. It's truth. Yeah, no, I don't think it's not coming from the mixer. I'm not hearing it on the headphones here, so I don't know. Interesting. Anyway, thanks for letting me know about that, Graham. I don't know whether it's coming from here or whether it is perhaps an atmospheric effect of some sort. I don't know. I doubt very much that my signal is going around the globe and coming back here. That'd be a first on 80 metres. Oh dear, you get that sort of thing happening on 10 metres, don't you? It's been a long time since I've noticed that. But anyway, doesn't matter. All right, thanks for that. Actually, there's a device that's coming, something I got off Facebook, and it's coming with its own microphone. It's a little audio thing that that can do a few amazing little things. And there was just a couple of things that the person illustrating it, I thought, oh, that's interesting. And there's a pre-recorded clap track. So if you want the sound of people applauding, you hit this button and you get people applauding you. But there's also an auto-tune feature, which has something to do with tailoring your audio, so it sounds a little bit different or better. It also has the ability to change the sound of your voice so that you can go from a super cool ABC radio announcing type voice to some sort of feminine sounding voice, apparently. Don't know about that. But I think the other thing I liked about it was that if you were playing music and you suddenly spoke over the music, the music automatically attenuates down while you're talking, and as soon as you stop talking, the music fades back in quickly, and that's a little feature that I thought might be a bit of fun to play with for something else. So, but yeah, that's on its way and should be here fairly soon. So I'm looking forward to having a bit of a play with that, and whether I can factor that into the scheme of things here, I don't know yet. Anyway, enough of that gunge. Thanks, Gray, and you just let me know if that echoey effect has been noticed in this last transmission. VK3GL, VK3CSJ, EKH.
VK3, EKH, VK3GL. No, nothing on that last over at all, Clint. And it would be interesting if it was actually a mixer, but I don't think it was. It was like when you were talking during the broadcast tonight, there was a period there where it was evident for about 20 seconds, 30 seconds or so, and then it disappeared. But it was just this very, very, very slight echo. As I said, a little bit like what they use with a lot of live music artists, and that they like to have a little bit of high ambience on their voice when they're singing. It was a little bit like that from my observation. Anyway, there we go. Yeah, well, who knows? It was just an interesting observation tonight. Alright, I'll let you tie the ribbons anyway, if that's what you're going to do. I'll see if there's anyone else wishes to check in. But if not, if you want to, we'll have a few words after you've finished things up if you want. I'm not too sure how long you're hanging around for, but I've got about half an hour or so before. Well, I'm actually not off work at 12:15, so if you wanted to have a bit of a chat about things, then we can do so. Alright. I'm using the FT7 by the way tonight as well. VK3, KH, VK3GL.
Yeah, I can see it's just slightly off frequency, but not by much. Yeah, okay, Gray. No, I'll depart the scene right now. Doing an